Good morning, everybody. A warm welcome to you all on this beautiful morning to the National Space Academy's Online Careers Conference. This webinar will run from 10:30 a.m. until 12:30 p.m. We're recording the event and hopefully we'll be releasing some of the recorded video for others to watch after the event. Your cameras are switched off and your microphones are switched off, so there's no video or recording of you during the event. If you want to talk to us, there's at the side of the screen, that way, or yes, that way, I think, there's a little chat box at the side. You can use that question and answer facility to type in your questions for the speakers. Attendees will not be able to see each other's questions, only the organisers will be able to see the list of everyone's questions. Any inappropriate use, of course, will result in you being muted and booted. So during the presentations, we've got 3 people coming to speak to you today. Obviously, you're only seeing 3 people now, but in the new year, we are going to be releasing videos of 8 more people, who include things like space lawyer, space artist, aerospace engineers, and things like that. So during the day, you can, while you're watching the presentations, you can send in your questions, but we're going to do all the questions and answers at the end of the process. Our first speaker, Sofia, actually has to run off to another appointment straight after her presentation. So if you've got any questions specifically for her, say this question's for Sofia, and we'll be able to pass them on to her, and she'll be able, we'll be able to get back to you at some point in the future. Tell you what, why don't we just very quickly check that you can all use the questions box. If you type in where you're joining us from today, that would be absolutely brilliant, because it'd be interesting to see where some people are who are watching today. So Moki is in Yakeley, Luke is in Ascot. My goodness, everyone's going for it. Yeah, Ethan is in London. Olin is in Barrow-upon-Soar, that's just down the road from us. Mikasa is in Birmingham. David is in Rugby. Tom is in Essex. Wow, everybody is kind of joining us from all over the country. That's absolutely fantastic. Okay, stop that now, because we've got to delete them. Oh wow, Jedon's from Bodmin in Cornwall. That's probably the furthest away that I've seen just now. So that's absolutely fantastic. So I'm going to introduce you now to the first of our speakers, who is Sofia, and she's joining us from RAL Space in Oxfordshire. I'm going to let her introduce herself more fully, but her name is Sofia Fuster, and she's going to talk to you about RAL Space. I'm just going to hand over control of the screen to her. Have you got it? Yeah, that's great. We can all see that now. Brilliant.
Amazing. Thank you so much, David. Okay, well, hello everyone. Thank you so much for letting me here speak to you on this Saturday. I'm really excited to speak to all of you in year 10 and 11. I remember it being a really exciting time for me in terms of getting into the space buzz and getting more interested in it. So hopefully today I'll be able to tell you a bit more about my journey during these last couple of years in the space industry, where I work, which is RAL Space, and how you can get involved in the future with us maybe. So first of all, here you can see a really lovely image of our timeline of all the activities we were involved over the last 60 years. RAL Space has really been contributing at the forefront of the space industry in the UK. And I work here at the moment as a product assurance engineer. But before I dive into RAL Space and everything we do, I'll just start with a brief introduction about myself so that you know a bit more about me. So first of all, I am actually from Spain. I'm Spanish. I am from Valencia, but I've been living in the UK for the past 6 years. And actually, it was around your age when I started getting interested in the space industry. I remember I used to go to events such as this one you can see here in the bottom with astronaut Samantha Cristoforetti. She was the female astronaut of the class of 2009. And I got to meet her at an event from ESA in the Netherlands when I was 17, so when I was in year 12. And that was incredibly exciting. I also was able to attend courses in space industry. I remember I did an astrophysics course over the summer. I also went to London one summer to do a STEM course, and I remember I got to visit Airbus, and it was really exciting. And I also used to write articles interviewing scientists, interviewing people in the space industry, and I got them published in my school newspaper, in a few international magazines aimed at young people. And all of that just kind of got me really excited because I really liked space and I knew I wanted to be involved in space. So during my GCSEs and A-levels, I made sure to kind of choose subjects that were available to me. There were a lot of them, many around STEM subjects, such as chemistry, physics, maths, and further maths that I did during my A-levels. But also I did some less conventional topics, such as business and psychology during my GCSEs and Spanish literature in my A-levels, which at the time didn't seem like they fitted, but over time I've realized they're actually really useful, because to be able to work in an organization and with people specifically, you need to understand business, you need to understand communication skills, and all of that is things that are taught in humanities subjects, as well as how to write really good reports, which you learn through literature and writing essays. So I really encourage you to also reach out and do something a bit different, because it will be really good for you in the future. So moving forward, after my A-levels, I moved to Cambridge in England to study aerospace instrumentation and control engineering. And that's where I was for 4 years during my MEng degree. And after graduating in 2020, I went to STFC, which is my organization, to do the graduate scheme. And that's where I've been working. I am currently a product assurance engineer, and I will explain shortly what that means. And I work at the space department in STFC, which is called RAL Space. So before I explain what I am doing at the moment, I thought I would just give a brief overview of the different roles I've done over the last couple of years. So during university, I got involved with a couple of summer placements. As you can see, they were a bit scattered, but they were a really good foundation towards working in the space industry. And I really encourage you to get as much experience in the summer as you can, especially if you want to understand what kind of role fits you in the space industry. So for example, in the Netherlands, in my first year, I went to a town called Delft. Delft is really known for having a lot of space companies. And I worked as a space systems engineer. So I was working on a very technical role, and I worked on developing a mission proposal for the European Space Agency on sending a constellation of CubeSats to the moon. So a constellation just means a group of several small satellites, which is what CubeSats are. As you can see, they have a cube shape, so it's a very descriptive name. Then in my second year, I went to Oxford to a company that was developing the parachute system for the ExoMars mission, which is once again a mission from the European Space Agency. And they needed to model as closely as possible how this parachute was going to function when it arrived into Mars and it was going to land that rover and that landing probe. So for that, I worked on as a thermal engineer, and I was helping develop these models that were trying to replicate what we were seeing in our experiments as closely as possible, so we could predict how data was going, well, how heat was going to flow during that process of landing in Mars. And that was really exciting. Then on my third year, I actually decided to do something a bit more different. I wanted to do something with public engagement, still related to space. So I ended up traveling to China, to Guangzhou, which is next to Hong Kong. And I worked on the Cambridge Summer Schools in China project. And I just worked with a lot of young people. We were making rockets, we were launching water rockets, investigating materials. It was a very hands-on workshop I did with them. It was really fun. That's a picture of the whole team that we worked together. And it was one of the best times I've had, because I've never been outside of Europe, and suddenly I was in China and I had a really good time. And then finally, yeah, after university, I started working at STFC. And I'm now working as a product assurance engineer in the Harwell campus, which is also south of Oxford, like my second year company. And I'm supporting space missions at both national and international level. And this is a picture actually from my office. We have several buildings, but my office is actually, I like to think, is the nicest one. It's a really nice building. Okay, moving forward, what exactly do I do? So I think it got stuck. 1 second. There we go. Okay, so space product assurance. I really like to begin explaining what product assurance is with this picture. So what you can see here is a satellite from the National Oceanic and Atmospheric Administration from the United States government. And as you can observe, it's kind of fallen from the loading cart. And this was a very, very expensive accident. It was being tilted by the manufacturer, Lockheed Martin, and suddenly it fell. And the repairs were valued at $135 million at the time. And this meant that the manufacturer lost any profit it had on the project, years of delays, an absolute disaster, basically. And what happened? Why is this related to product assurance? So actually, when NASA investigated what went wrong, it discovered that during the storage period of the satellite, one of the engineers decided to unbolt the 24 bolts that were like connecting the satellite to the plate that you can see on the screen. And he didn't document this. He didn't write it down anywhere. So nobody knew this has happened. And furthermore, when they were going to tilt the satellite, the engineers in charge of this activity did not follow the procedure. And the procedure said, please make sure that you check that all the bolts, are correctly torqued, they're all in place. And they didn't do this. So basically they started tilting the satellite and it just fell. It just flopped on the floor. And it was a very, very expensive mistake. So yeah, not following procedures and not documenting resulted in a loss of $135 million for the manufacturer. And this is exactly where product assurance comes in. This is one of the responsibilities of my job. And we work to prevent this from happening, basically. So giving a more broad description of my role, product assurance is basically an independent role that happens in every space project. And their role is dedicated to studying, planning, and implementing activities to make sure that the final product meets its intended purpose. And now here, product can mean a range of things. It can be anything from a really small component to like a satellite to a facility like the one you can see on the screen, which is one of our test chambers that was being built a couple of years ago. PA, as we call it, is always involved in all these missions and projects to make sure that we're really delivering what we were intending to do. And how do we help? Well, there is a whole range of tasks I have to do in my day-to-day. An example of that is, for example, ensuring activities are safe and appropriate, so nobody's getting hurt and we're not damaging equipment like you saw in the previous slide. We also verify that materials and processes are fit for purpose. We are the customer representatives on site, so we represent the customer's interest and we make sure that we're really delivering what they asked us to do. We also track problems, such as what you saw in the previous slide. When something goes wrong, we're the ones leading the investigation and making sure we resolve it, that we find the root cause, that we make sure it doesn't happen again. We also inspect activities and hardware, and we basically approve and sign off anything and everything that affects the product. So they kind of know us a bit as the ones with the rubber stamp that just goes around signing around documents and making sure everything has our approval before it happens. And why is this important? Well, it's really important because it minimizes errors in a project, and errors are quite expensive, and also they result in a schedule delay to the company, so nobody wants those. And also it makes sure that the customer requirements are met. So the customer is happy, we deliver what we promised, and that means the mission succeeds and meets its objectives. So now moving on at what RAL Space exactly is. So RAL Space is actually funded by the government. If you look at the following diagram, you'll see that the government is made from different departments, one of which is the Department for Business, Energy, and Industrial Strategy. And that is an umbrella organization within, basically it funds a lot of organizations, one of which is UKRI, UK Research and Innovation. And UK Research and Innovation is founded by now 9 councils, one of which is called STFC, which is the Science and Technology Facilities Council. And STFC is all around the UK. We have a place in Edinburgh, in Bowlby Underground Laboratory, in Oxfordshire, where I work, Chilbolton, Swindon, and finally Daresbury, which is located between Liverpool and Manchester. So we're all around the UK with these facilities, focusing on science and technology, particularly nuclear physics, particle physics, and space. And yeah, and I work within RAL Space, which is the space department within STFC. Okay, so now to introduce RAL Space, I'll just show a brief video for all of you, and then I'll move on explaining what you've seen. Okay, so hope you enjoy that. So moving on, that was RAL Space. And what exactly do we do? I hope you're seeing my screen. I think you are. So moving on, what is RAL Space? So RAL Space is the UK's national laboratory advancing the understanding of space and our environment for the benefit of all. We are based, as I said, within STFC, the Science and Technology Facilities Council, and our work really spans a whole range of disciplines in terms of scientific research, such as climate science, space weather, and astronomy. We do a whole range of activities. Most importantly, we support research and development for the use of space by academia, government, and industry. We focus on fields such as heliophysics, infrared astronomy, climate atmospheric composition, quantum technologies, radio propagation, and the list goes on. We help design, build, and calibrate and test space instruments. At the moment, over 211 instruments have been developed in our facilities, including, well, in addition to ground-based instruments. We also help develop key technologies such as electronics, detectors, optics, robotics. We have data, algorithm, and information centers. And finally, we also help design, build, and operate national space facilities. And this spans a whole range of facilities such as data facilities, such as Jasmine, the Chilboton Radar, which focuses on space debris surveillance, and the National Satellite Test Facility, which is going to be the largest space facility for testing satellites in the UK. Not only that, we are also involved at all stages of a space mission, from the beginning where we do the study for what the mission could consist of, to designing, building, testing, and calibrating those instruments themselves. And then once they're in space, we help operate them, the instruments and the spacecraft, and we communicate with them to downlink the data and then later on process and analyze it. So we're involved from beginning to end of a whole space project. In fact, there is a project at the moment you may have heard of, and that is MIRI. So MIRI was one of the 4 instruments. I'm not quite sure if I'm going to get this video to work. So anyway, there was a video here about MIRI, but the James Webb Space Telescope, you probably have heard about it. It was a collaboration between NASA, ESA, and the Canadian Space Agency. It was the replacement for Hubble, and the UK led the team making MIRI. So we made sure that this instrument was tested at our facilities. The assembly, integration, and testing happened, and this included vibration testing, thermal testing, metrology, and alignment testing. And that was quite fascinating to be able to be involved in one of the 4 instruments of the James Webb. And in fact, here you can see a couple of images of MIRI. The first one shows MIRI on its own. So this is like it focuses on a specific part of the electromagnetic spectrum. However, when you overlay MIRI with the results from the other instruments, you can see that you obtain a much richer image. In this case, this is with the NIRCam, which focuses on another part of the electromagnetic spectrum. And as you can see, the results are quite fascinating. And it's very exciting for RAL Space to have been involved in such a high-level mission. Okay, moving on, I will give now a brief overview that we're involved in many, many projects. However, I will talk about the ones I know about, which is the ones I'm working on at the moment. And hopefully that should give you a really good oversight of everything we do at RAL Space. So first of all, there is Ariel. So Ariel is a mission funded by the European Space Agency, and it's a space telescope. It's going to go to deep space, and the goal of Ariel is to study the exoplanet atmospheres. So how is it going to do this? Well, it's going to do this by looking at planets in very distant galaxies. And when the sun goes below the atmosphere, we're going to be able to take readings of this region exactly. And this region is going to then show us in the electromagnetic spectrum specific elements that may be available in that atmosphere, which could indicate there is life. And it's going to explore over 1,000 exoplanets. And yeah, and this instrument, which is the one you can see at the top, it's going to be tested and assembled at our facilities, and we are leading the consortium for this. Moving on, we've got the Sentinel-4 and Sentinel-5 instruments. Now, these instruments are used for Earth observation, and they're being done by Airbus. However, they are being tested at our facilities, so it's really exciting for me to be involved with them as well. So once again, these instruments, they're used for Earth observation, so they're looking down on Earth at our atmosphere, and they're funded by the European Space Agency and the European Union. And they're monitoring key quality air parameters such as nitrous dioxide, ozone, sulfur dioxide for the case of Sentinel-4, and carbon monoxide and methane for the case of Sentinel-5. And they're also at different heights, if you want to call it, from the ground. Sentinel-4 is going to be on a geostationary orbit, which means it's always looking down at the same part of the Earth, whilst Sentinel-5 is going to be in low Earth orbit. And this means it's going to be lower down, and it's going to be able to see different parts of the world because it's always going to be moving in relation to the Earth. And as I said, the calibration of both instruments has happened at RAL Space. So we are very proud to have helped make these two incredibly useful instruments, especially when it comes to climate change and understanding how our planet is working. Moving on, another Earth observation project. In this case, it's called Cubemap. It is also founded by ESA, but this is quite a very new approach to projects. So this is actually known as New Space. And why is that? Because this is actually a CubeSat, a 12U CubeSat, and it's going to be launched in a very short period of time. It's going to be built and developed over 3 years and in orbit by 2024. It's part of a constellation, which means it's a group of satellites working together. And it's part of the first time that ESA does CubeSat, if you want to call it. So it's really exciting. It's also monitoring greenhouse gases, such as carbon dioxide, methane, ozone, and nitrous oxide. And once again, we are building, we are designing, and we are testing these instruments at RAL Space. So we are very, very proud to contribute to this really novel approach to space missions. And I'm really happy as well to be involved on making sure that we're making it right as a product assurance manager. Finally, there is Spectre, and Spectre is a bit different to what I've described before. It's actually working on quantum key distribution. And quantum keys are a very secure form of communication that you can do between a satellite and a ground station. And here's an image of the rendering. As you can see, it's also a CubeSat. And this is actually a collaboration between the UK and Singapore. It's going to be demonstrating that you can transmit a quantum key between the satellite and the ground station. And this is going to be quite revolutionary. It is not been done yet to many different scales. But here the UK is leading the way with this kind of technology. And we are designing, building, and testing at RAL Space. And we are actually in the middle of building this at the moment. We are expecting to have it ready for December next year, so we can launch it in 2024. And here you can see what goes in. This is a really small satellite. It's about the size of your laptop. And as you can see, it has many different components, from the electronics to the cameras that look down on Earth to the quantum key distribution technology that goes within it that's being developed in Singapore. So it's going to be quite a revolutionary mission. And I really hope that when it goes out in a couple of years, you'll be able to see it and know that it was done here by us in the UK with the assistance, of course, of Singapore. So yeah, so talking a bit more about my role in the organization, I've been part of the STFC graduate scheme, and this is a 2-year program that starts in September every single year. The recruitment usually happens in October to January of the previous year. So although it's a bit away from you because you're still at school, it is something to keep in mind towards the future. If you ever, if you go to university and want to get involved in a graduate scheme, just so you know that here at STFC and RAL Space, we have this available. We work on soft skills training, such as communication, leadership, teamwork, and also a lot of technical training, which is just provided depending on your role. And this is training courses, shadowing more senior people at the company. And as well, as part of the graduate scheme, we got to do a 3-month placement. It can either be internal within STFC or external, going abroad to CERN in Switzerland, to the US, to any collaborating institutes that work with us. And in my case, for example, I worked with the Ariel mission, which I talked before, but instead I worked in systems engineering. So I was part of the technical team that was helping develop all that process that we're going to need to have in place to test Ariel in a couple of years. So I helped to define the electronic equipment that we were going to need, how it was going to talk to each other, everything we were going to require to make sure that our tests were fulfilling the requirements, if you want to call it like that. We also got to do a graduate project. In my case, I focused on green walls. So here you can see a couple of images of green walls. I think it's a fascinating technology because it's a way that you can capture carbon from the air. And what we did is a team of 10 graduates. We worked with the STFC head of sustainability on assessing if this kind of technology could help us meet net zero goals, which is one of the objectives that STFC has in mind. So that was what we did for 7 months as a part-time job at the same time as we were doing our usual jobs. I also got involved in the graduate conference, on team building trips, and as well as charity challenges where we were fundraising money for good causes. And of course, you got to get involved in public engagement like I'm doing at the moment. So there's definitely a lot to do at STFC, and I hope that maybe gives you an idea of what would you like to do in the future if you decide to join us. So finally, I would just like to talk briefly about the roles at RAL Space. I've divided them into 3 sections. First of all, there is the bigger picture roles, if you want to call them. These are the kind of roles that have a really good oversight of the project in terms of management. And for that, you've got product assurance manager, which is making sure we deliver what we promised. The systems engineering lead, which is a technical role and make sure that all the engineers are working together on their different areas. The project manager, which makes sure that we don't exceed the budget, that we have enough resources, that we are meeting the schedule. The principal investigator, which is usually a scientist, and it directs the science objectives of the mission. And finally, you have roles like procurement and project support, which make sure that we're getting all the right resources into the project and that we have enough people supporting us. Furthermore, you may be interested actually in working something really specific and really technical and state of the art. And for that, we've got specialist roles such as optical scientists, thermal engineers, mechanical engineers, and software engineers. They all work in their specific discipline, creating a subsystem, and then it all integrates together to form the space product. So if you actually would prefer to do a mechanical course or engineering degree, or actually focus on software or data scientist, there is always something available. A space mission requires every single set of skills. So this is something as well that you could be doing. And finally, we've got what we call hands-on roles. So these are the people who are there in our facilities, making sure that all the tests run as expected. We've got, for example, the environmental test division, and that includes dynamics, which are all the people involved in vibration testing. And this involves basically shaking the spacecraft and the products to make sure that they are surviving the launch phase of the project. We've got the thermal vacuum chambers, which is what you can see in the image. And these are just really big cylinders that we then hold at a vacuum. And we put all of our products inside and we make sure that they're working as expected by simulating the space environment. We've also got the electromagnetic chamber, which is once again a chamber that we use for testing electromagnetic performance. And finally, the ground support equipment. And the ground support equipment is everything we will use here on Earth to communicate with the satellites. And that involves also a whole array of people who are making sure that we can get all that instrumentation in place to communicate with it. And finally, we've got production. And production are the people who actually build the spacecraft. And we call it AIV, which stands for Assembly, Integration, and Verification. So what next? Just to finish off, a quick overview of everything that's available at RAL Space and STFC. We've got the graduate scheme, of course, which is after university. But before that, there's a lot of ways you can get involved with us, such as industrial placement students. And this is during university. You can do it during the summer, one of the summers during your degree. We've also got summer placement students, which is during university. Oh, wait, sorry. Industrial placement is for a full year during university, but summer placement students is only during the summer during university. However, for you, you can actually get involved with us right now as a summer work experience student, and that is available from years 10 to 13, and the applications open in January. So do please get in touch if this interests you. It's all on our website as well, and you can come over for the summer for a couple of weeks, work with us, see what we do, and get involved. And finally, if after your GCSEs you would like to do an apprenticeship, we've got a really big apprenticeship scheme here at STFC. I've put the website link so you can find out more about that, but it might be something that interests you to get involved right away full time. And as always, if you have any questions, just contact us. And thank you so much for listening to me today. And I hope this has been useful for you.